Good morning, everyone. It still is morning, and thank you all for your efforts to come to Saskatoon to this CFI event. I'm just going to ramble a bit as you find your seats. My name is Mark Boland. I'm the Machine Director at the Canadian Light Source and a Professor in Physics here at the University of Saskatchewan. And it's great to see so many of you here. And it always amazes me that it takes an event like this for me to meet some of my colleagues who are right here on campus. So we do have a lot of CFI people here, CFI-funded facilities. So we're very grateful for that, and it's great to have so many people here celebrating our facilities and all the great science that we can do. So our panel number 3 is entitled Keeping Canadian Facilities at the Global Forefront as Technology Rapidly Changes and New Opportunities and Challenges Arise. This is quite a mouthful, but we have very excellent panelists here who will make sense of this for you. We have Navid Aziz, CEO of CGen, Francois Legare, Scientific Head of the Advanced Light Source ALS, Warren Wankrachuk, who's the Scientific Director of GlycoNet, and we're going to first hear a brief presentation from each of our panelists to introduce their facilities, and then we will go through the panel discussion. So to start, I will bring up to the table, to the lectern. Please join me in welcoming Navid. My apologies, the slides are in a different sequence. So, Warren, please.
All right. So, thanks for the invitation to be here to tell you about one of the new MSI facilities that was just funded this year. And the name of the facility is GlycoNet Integrated Services, and I'm going to tell you a little bit about its history and its mandate and why we think it's very interesting. But before I do that, I need to give you a 45-second biochemistry lecture. I realize many of you in this room don't know what glycomics is, but this cartoon that was put together by my graduate student sort of depicts a cell that is covered with this chemical structure called a glycan. And glycans are just sugar structures that are put together in various three-dimensional forms, and every cell in your body is covered with these glycans. And because of that, they dictate all the interactions that happen between cells. So a good example would be your immune system. So in order for your immune system to make antibodies, T cells and B cells have to talk to each other, and that can't happen if the glycans are not right. So that's, I think, a very good example of why we should care about glycans. So because they're intimately involved in health, obviously they play a role in disease. And one of the problems that we have, of course, is that this spectrum of three-dimensional chemical structures that are sitting on our cells is not directly encoded in the DNA. So sequencing a cell won't tell you what the sequencing the DNA in a cell won't tell you what the glycans are. Sequencing the transcripts won't tell you what the glycans are. You really have to look for the glycans because they're temporally and spatially regulated. So that's the end of my biochemistry lecture. There won't be a quiz. So glycomics has a long history in Canada, and I don't have time to go through that, but it came out of organic chemists wanting to understand how these complex molecules were put together. And offline, I'd be happy to tell people a little bit about the spectrum. But suffice it to say, Canada is one of the world leaders in carbohydrate chemistry, carbohydrate interactions, glycobiology in general. We once had a comment that Canada punches well above its weight class when it comes to glycomics. And of course, when you're putting together an MSI, you have to put together this competitive analysis of where you sit. And one of the things that we do, I think, which is maybe slightly different from some of the other facilities, is we have a number of different services that we offer that are vastly different. And we went through and we identified a bunch of very unique things that is really unique to the Canadian experience. And so we do have this draw then of having unique capabilities which brings people to our facility. Now, what is our facility? Our facility is a distributed one. It's across the country. And as I mentioned, or maybe I didn't mention, GlycoNet started as an NCE 8 years ago in 2015. And so we build up this research network across Canada. There are roughly 193 labs that are involved in this network. And what became the MSI was our service arm, if you want to think of it. So we had analytical facilities built into the NCE across the country. And those facilities were in 7 different places across the country, which all have unique expertises, and I'm not going to go through all of them, but we have one in BC. We have the main one in Alberta, which is where the administrative center for GlycoNet Integrated Services is. We have 3 facilities in and around the Montreal area. We have one in Hamilton at McMaster and one at the Spark Center at the Sick Kids facility in Toronto. One of the things that came up when the panelists and Mark and I were discussing what we were going to talk about today, we talked a little bit about governance, and I thought I would just mention it because our governance model might be slightly different from some of the MSIs. So GlycoNet Integrated Services is part of GlycoNet. It is not an independent entity. And because of that, we sit in a place where we have a board of directors, we have a scientific advisory board, which is all above the CFI MSI, and then the MSI, of course, has a steering committee and other things. But at the moment, it is part of the network structure, and so it is part of the governance structure of the network. So we were asked to talk a little bit about challenges and opportunities that we have, and I thought in order for me to do that, what I needed to do was to describe what we call our sort of pipeline of services. So being involved in the biomedical sphere, then we're very interested in taking basic biology and pushing it toward therapeutic avenues as the research goes. And so, of course, there are various analytical steps along the way. And I picked 2 examples from this pipeline that I wanted to zoom in on. So if we just take this sort of idea of glycan structure determination, so that's something that's relatively involved depending on the complexity of that glycan. The glycan could be 1 sugar, it could be 2, it could be 12, or it could be 100. And so there's a lot of difficulty that you might run into. So one of the problems that we have is integrating the databases that collate where these structures occur, the proteins they interact with, and the genomics and all of that information. So one of the opportunities that we have then is we have experts within the network who are applying artificial intelligence and machine learning to try to parse all of these different databases to try to make some biological sense of all of this information. And I think I wouldn't be the only one to say that trained personnel for many of us are hard to find. And so we have the opportunity to provide training to keep this expertise in Canada. And everybody will have seen the 60% matching, and I probably don't need to talk about that more at the moment. One of the other challenges that we have is that in the biomedical sphere, people are moving away from the sort of standard cell lines and wanting to use patient-derived cells in order to look for drug efficacy. And we have some experts within the network at our high-throughput screening facilities who are experts in taking patient-derived cells, and they really are at the forefront of using these cells for screening for any kind of drug candidate that would be involved in a therapeutic based on this sort of glycan interaction. So we have that opportunity. We also have, I think, probably some of the best people in the world in this chemical biology sphere looking at how to apply glycoscience to the therapeutic world. And I think Mark is going to yank my... So I have one slide left. So where are we going? One of the things I wanted to mention is that we have very heavy reporting requirements, as do all of the MSIs. We have an extra layer of complexity in that we have 7 different locations that we need to get information from. So one of the things that we've been developing is an internal LIMS system, which helps to collect the data and generate a report in a format that the MSI would like to see. And I'd be happy to talk to people if you're interested in where that LIMS came from and where it's going. It's still in development, but I think for us to collate all of this information from 7 sites, including financial information, it's really important. Our technology development is very strong, and this is helping with attraction and retention of HQP. But going back to that matching question, sometimes it's a little hard to think about where that 60% of the salary dollars are going to come from. And one of the things that we've been struggling with a little bit is that services for academics are expensive. And so not everybody who's in an academic setting who could take advantage of our facility can do so. And it's not always possible to offset that with the company-sponsored analysis that we do. And so with that, I will stop.
Thank you very much, Warren. It's great to see that juxtaposition with the challenges, the opportunities, but also the great successes and how we are punching above our weight here in Canada. So thanks for that overview. And now, as promised before, I'd like to invite Naveed.
Thank you, Mark. Okay, green go and red stop. Okay. Thank you very much, Mark, and thank you everyone for being here. Thank you to CFI for giving me the opportunity to speak to you about some of the things that are near and dear to my heart and to CGEN's heart. So the idea here is I don't want to be telling you a lot of things and just talking to you. The idea is a little bit of that, of course, but the idea is to put some ideas forward as to what we see the challenges, opportunities around rapidly changing technologies, and be maybe a little bit provocative and hopefully elicit some discussion. So that's what my intent here is. Let's see if I'm successful in that. So let's get the talking part out of the way first. So CGEN is Canada's national platform for genome sequencing and analysis. We are in our 2nd round of MSI funding. We have 3 sites across the country in Toronto, Montreal, and Vancouver. On the MSI payroll, we have about 260 FTEs, and our annual budget is about $20 million. Most of our, and we'll talk about this in a second, but most of our match for the MSI comes from our user fees. And this is a very busy slide, and I would not spend a lot of time on this, but our mission is really to kind of make the CGEN as a national facility for advancing genomics in Canada and supporting genomics in Canada, working in 4 core competency areas: data generation, which we do a lot, data stewardship, tools development, because we have to stay ahead of the curve, and we'll talk about that in a second, and then talent development as well. And I have a few things to say about that, especially after the user panel we had earlier this morning. So user-wise, we have about annual 1,000 users for CGEN. Now, this is where I wasn't going to spend some time, but apologies, Mark, I'm going to spend an extra minute or so on this, and I especially want CFI colleagues to take note. So our definition of users is very strict. When we say user, this is each individual PI laboratory that come to us to ask for service. That within that laboratory, there might be multiple projects, and they might have multiple co-PIs working within that laboratory, sometimes 5, 6, 8. So the 1,000 number you see here is strictly the number of labs that come to get service at CGen. If we want to redefine as each individual, this number could be 6 or 7-fold higher. But when we report to CFI, we only report the 1,000. So that's how we have defined. And then I heard other MSIs talking about users as people using the data. We don't even count the number of people that use the data we generate in our users. That number we count in a different category is around 3,000 or 4,000 every year, about 15,000 since we had started. So maybe there's a little bit discussion mark to have around how we redefine either ours or others to make sure that you guys can compare apples to apples when we provide those KPIs back to CFI. So that's my spiel on users. Coming back to the topic itself. So as Warren said, we were asked to talk about the rate of technology change and how do we deal with it. I'm going to talk very briefly in 3 buckets, and it's brief. The first one is managing rapid change in technology and in the technology itself. So one of the things we deal with every day is the user needs and wants. And what I mean by that is there are, especially in the area of genomics, there are technologies that we see are required by researchers and globally that move genomics forward within the ecosystem. But then there are a lot of other smaller technologies that when users hear about it and in Genome Web or Illumina announces some cool new technology, every user would want to have access to that. They may or may not have real need for it, but they want it. So we are constantly, and Steve Jones is here as our scientific director, you could talk to him about that. We are constantly trying to balance. We don't want to be telling them, well, no, go away, but we're trying to educate and balance constantly and as to what we can bring to the lab. And it's not easy bringing these because there's training required for people who are going to use it, and there's a requirement of assessing the technology and bringing it into mainstream use. So we can't have every technology in the facility, but where CGen does best is because we have 3 sites. When there are new technology that comes in, we don't all have to test them out. One of the sites will take a lead on a certain technology, test it out, and if it makes sense, then other technologies will bring it in-house if they need to be, or we can just divert all countries' needs to one facility. So that's where having 3 nodes really help us. And the other point on technology, I would say, is also the pressure from manufacturers. So because within the genomics area, there's only a handful of manufacturers who provide these latest technologies. When they come up with a new technology, they want to sell the new technology, they want to sell consumables of the new technology, they very quickly make the older technology obsolete. Even though when they are nicely working and good, they will make it obsolete. Now the challenge is twofold. One is for us the expense to update the technology, but then also we have projects that are 3-4 years long and are running on the previous technology. We can't just shut it down and move the project to a new technology because there's a lot of comparative work that needs to be done between new. So there's a constant pressure on updating the technology and associated challenges. And associated with that is the need for HQP training and retention. So here's a challenge, but there's also an opportunity because what we find, again, Steve can talk to that more, that a lot of people who like to be close to where the data is generated and like to be tinkering with new technologies and playing with new technologies, they're attracted to come and work for us and with us because there's not a lot of places in Canada or globally where you can go and play around with $1 million machine and then go home. And if it was me, I am now in the lab, I would not be sleeping at night because I would be worried that I'll break something. So there's people who we attract because of that. So it's a challenge to update the technologies, but there's an attraction. But then the challenge becomes these people get trained, they get really good, and industry offers them twice the salary, and they're gone. So retention is a constant issue. The good ones disappear. Okay, I'll leave it there. And then the last point I want to talk about was match funding. I'm going to not dwell too much about it, but the reason I did put it there was that CGen is a little bit unique, and I'm sure others are similar, but not all will be the same, that the cost of doing genomic services and genomic sequencing is coming down every day. And we are very good at passing that saving to the user. But the problem is that because we are depending on our fee-for-service so much, we have pretty much doubled in the last 2 years the amount of data we output. But the cost of charging people, cost of fee-for-service is reduced because it's getting cheaper. So when we try and look at our match for CFI, it's going down, although we're doing more work. And then also related to that is this predictive challenge where when we are writing the CFI application, we have to predict 6, 7, 8, sometimes 8 years down the line what the cost of technology will be, and then also what you all do is how much work we will be doing. So that becomes really challenging. We, of course, then, like all of you, have to go to other sources of funding to find other sources of funding. Not so easy in the genomics area. I'm sure a lot of them will say the same thing, which is true that it's not so easy, especially when you're an CFI MSI. Other funders look at you, well, you're an MSI anyway, so why are you coming to us? But this is it's a current challenge. I'm done, Mark. So last slide, I just wanted to put that. So we created this diagram last year in our first iteration of the MSI in trying to explain what CGen or what CFI value for CGen is. CFI really makes this bridge that is CGen possible, the CFI MSI, that not only unites the three nodes together, but then supports all the other research that's funded by other organizations. So if it wasn't for the CFI MSI, this bridge will now be there, which will obviously make genomics in Canada or servicing genomics in Canada very difficult. So my thanks to Roseanne and Muhammad and Mark and everybody at CFI that not only providing us with this opportunity, but also for constantly, and you talked about that, Roseanne, this morning, for constantly going out and being on our side of the court and battling for more money for the MSIs because, again, these are basic research infrastructures for the country and needs to be running, and it's not easy to run these big or small facilities. I'll stop here. Thank you.
Thank you, Naveed, for an excellent sequence going through our challenge for this panel. And now, please, over to Francois to talk about owls.
So, hello everybody, my name is François Légaré. I'm the CEO of the Advanced Laser Light Source, which is located at INRS near Montreal. With me, Steve McLean, the co-chair of the All Strategic Planning Committee from Infinite Potential Laboratories, Haida Ibrahim, who is the new director of the Advanced Laser Light Source, Fabio Boschini, professor at INRS, and Sophie Lund from the CFI Liaison Research Service of INRS. So how to remain internationally competitive, cutting-edge infrastructure? We have to drive a thriving research field. We are working to help the 5 key innovation sectors of Canada. We have built an excellent team to lead internationally. And most important, we cannot compete with all these big laser infrastructures, so we have to focus on niches. So we cannot do everything, we focus on niches. So in 2018, the Nobel Prize of Physics has been awarded to Donna Strickland and Gérard Mourou. Both of them have been users of ALS for the chirp pulse amplification technique. Donna is also co-chair with Steve of the ALS Strategic Planning Committee. And what the chirp pulse amplification technique has enabled, it was discovered in 1985, it has enabled to further increase the laser intensity that we can get at the output of the laser. And out of this, we can do new science, relativistic optics, plasma physics, and in our days, quantum electrodynamics. But very importantly, through this fundamental science, we can generate particles, we can generate X-rays, we can generate electrons, we can generate neutrons, and those particles and this light can be used for applications. In 2023, very recently, the Nobel Prize of Physics has been awarded to Pierre Agostini, Ferenc Krauss, and Henri Lier for the development of attosecond science. As a student of Paul Corkum, you can imagine that I was hoping a different news on October 3, but I want to highlight how the Canadian community, under the leadership of Paul, has contributed to this science. And I remember, as a student, I was working on the 100 Sussex Drive in Ottawa with Paul, the house where Herzberg did his career as well, and it has been a real privilege. So what are those timescales? Here's the age of the universe, okay? Within 1 second, there's about the same number of attoseconds than the number of seconds within the age of the universe. What are those timescales? Well, a femtosecond is 1,000 attoseconds. If you take the hydrogen molecule and you look at its vibration, it's vibrating within 10 femtoseconds. So the Nobel Prize of Chemistry in 1999 was awarded to Ahmed Zewail for the development of femtochemistry. So femtosecond is very important to understand chemical dynamics. The attosecond is 1,000 times faster than the femtosecond, and it's the time scale of electronic motion. For example, if you take the hydrogen atom, you think of it as a racetrack. It takes 152 attoseconds for the electron to rotate around the hydrogen atom. So those are the time scales that we can address with modern laser technologies, and this is the fundamental science that we are doing. But as I said, those high-power lasers enables to generate particles, X-rays, within very ultra-short time scale, and it enables applications in all 5 innovation sectors of Canada. So, currently, most of the users of ALS comes from condensed matter physics, physical chemistry, physical engineering, optics and photonics, and material science. But with our strategic plan and with the support of the CFI to reduce the cost of access, we want to build a user basis that will capitalize on these sources and then further expand with people from biology, mechanical engineering, medicine, telecommunication, and so on. How to run this facility? The budget of ALS is about $1.7 million per year. So we are a rather small facility, and I always like to compare it to the F1, if you like, speed car. To run an F1 team, you don't need a gigantic team, but you need very highly specialized personnel. And this is the team that we have at ALS. Picture was taken in September. We have already hired many persons, so we have almost doubled the size of the team within the summer. And many of them have like a PhD degree in ultrafast optics. We really need highly specialized personnel to operate these lasers. And regarding the challenges, in our case, the nice thing with lasers, you can open the box and you can fix it yourself when you know how to do it. But you need to have like a PhD degree, or you need to have a lot of years of experience to repair those machines on your own. So we have been able to maintain our laser over many, many years without warranty contract service because we know how to fix them. Thanks to CFI, in 2002, the Advanced Laser Light Source was created under the leadership of Jean-Claude Kiffer. I have to say, already in the 70s, there were people at INRS doing laser research, and this has built the foundation, the ground, the technicians, the engineers that we need to operate these lasers. Because of this highly specialized personnel that we have at the facility, in 2014, we got a private donation with a total investment of $8 million to go from 200 terawatt to 750 terawatt. And then in 2017, we got funding to upscale the facility in terms of high average power laser. What is a terawatt? A terawatt is 1/10 to the 12 joules per second. I can tell you that's a lot of chocolate bars. The world production of electricity, if we turn on all the power plants, is 10 terawatt. How can we get 750 terawatt? Hydro-Quebec will not be able to provide that 750 terawatt, obviously. Well, we have 13 joules divided by 17 femtosecond. We put all the energy within very short light pulses, and during this very short instant of time, we get 750 terawatt of peak power, and this is how we can accelerate electrons, for example, to a GeV energy within that length. So, how to maintain the facility, cutting edge, state of the art. I mean, as I said, one very important aspect is the highly specialized personnel. So we have received this year funding from HANSERT to create a training program in ultrafast science and technology with 8 universities from across the country. We are building the community through an ALS workshop that we organize every year. And a few weeks ago, I have signed, well, I was the representative of the General Director of INRS to sign a memorandum of understanding with the extreme light infrastructure in Prague, in Czech Republic. The extreme light infrastructure represents 1 billion euros of investment in laser science in Europe, and because we focused on specific niche, we can work with them. Since 2019, we are the sole Canadian facility part of the LaserNet US network, which is funded by the US Department of Energy. So thanks to the US, we even receive funding from them to serve users that are selected by the network. Laser physics highly depends on building collaboration also with theoreticians. So we are building a theory group under the leadership of François Fillon-Gourdeau with Laura Romuno from University of Ottawa. So we want to join our expertise to further have impact in our field of research. One very important aspect here also is, I've been trained as a theoretician, as a master's student, is to provide the capability to theoreticians to propose experiments that could be performed at the facility, not always using the theoreticians to explain our results, but to let the theoreticians propose breakthrough ideas that then the experimentalists, we perform at the facility. So as I said, we focus on niche. There are 3 niches where we have focused. So thanks to the contribution of Sylvain Formeau and Jean-Claude Kiffer, there's a unique laser wake field electron acceleration source generating hard X-rays. And using these hard X-rays, we do plant imaging with people from Saskatoon, from University of Saskatchewan. We image lithium batteries with Sylvia Cipicia from the UK. We even look at the capsules. You know, you heard probably about the gain that they have observed at the National Ignition Facility for Laser-Driven Fusion. So we image the capsules with Félicie Albert from Lawrence Livermore National Lab and looking at additive materials, Amina Hussein from the University of Alberta. So we target applications that are relevant for the society. Then we are developing unique ultrafast laser technologies. So as I said, we can put our fingers in the laser. We can work on the laser ourselves. We can further improve the laser performance. So we can run lasers for 20 years. So we have a spin-off company developing these technologies with us and doing the commercialization. And these technologies that we commercialize are also available in the facility for all the users. And then the very last one, my colleague Fabio Boschini is building a unique end station to investigate ultrafast dynamics in quantum materials. The idea is to control the materials, to find new phases of matter for novel quantum technologies. And then we have a lot of collaboration with industrial partners. Since 2015, 22 Canadian companies have used the facility through collaborations with the professors using the facility. Thank you very much for your attention.
Okay, thank you very much for our panelists, and I've been asked to just very briefly contextualize the Canadian light source in relation to these facilities. So in a nutshell, we're over 260 staff. We run a facility 24/7 also for thousands of users. It's an interesting topic that Naveed brought up about how you count those users, but that we certainly service a large part of the scientific community across Canada. And our challenge is, as well as the matching, but accelerator technology is very expensive. So roughly 80% of our funding, around 35 million, is just to keep the lights on. And then on top of that, we need to get the end stations going to do the experiment. So it's a very challenging environment to upgrade that technology if there are lots of single points of failure. and we can't have the level of redundancy that we would really like with that funding model. Nonetheless, as with these other facilities, we still punch above our weight, and we have users that come here from all over the world, all over Canada, and they come here because we provide a unique capability and we have very dedicated staff. Similar challenges to attract them, but you can also, in that environment with the latest technology, you can attract people who want to come for love and money. So that's a little bit of context for me as chair, but we'll now go back and just restate the topic of this panel. And so it's keeping Canadian facilities at the global forefront as technology rapidly changes and new opportunities and challenges arise. And so with that, I was going to suggest that we first maybe just have a little bit of a discussion around and kind of get that matching funding bit out of the way. We've already heard from our panelists there, but if there's something more to say about that, let's get out of the way, because we don't want to dwell on the particular funding model, but also look at the successes and the opportunities. And so the maybe to kick that off is just on the one hand, it's good to have extended funding, but as we heard from our panelists, it is challenging then to plan ahead with those technology changes. We find the same thing at CLS, very expensive, multi-million-dollar amplifiers, the technology changes. So I'll maybe throw it open, and we talk a little bit about those challenges for the matching funding.
Mine says number 2. Oh, there we go. Yeah, so one of the challenges that we face, of course, is that regular grant money can't be used as matching, only in exceptional circumstances, and that it's hard then, as I mentioned, when you're servicing an academic community and they want a service, sometimes the price tag is just too high, and they just can't do it. And we have a couple of our nodes who work very closely with industry, and they charge industry 5 times what they charge an academic, and that's great for them. But we have some instances where we simply can't do it because of that matching.
Yeah. So again, the CLS also has different charging models. So for those who will publish, they more or less get the beam time based on merit, and then the commercial companies can come in and pay a higher fee to get access. Maybe Navid or Francois could comment on there.
No, it's the same for us, and it's not just commercial, but also international users as well. So we have some people using from the NIH, and they come and use our facilities. So the rates for them obviously is taking into account that it is taxpayers' money that we're running the facility with. So there's a difference in the cost of service.
Well, in our case, industry user fees are four times higher than academic. And then we receive money from LaserNet US that basically pays like industry. Then the government of Quebec also pays a bit. It's always challenging, but my main concern right now, the economy is doing really well. Companies want to have students being trained, so they approach us to build projects, and then through this training they use the infrastructure. But as it was mentioned, I don't know how will be the economy in 3 years from now. So will the companies continue to knock at our door in 3 years? Like right now, many companies are coming, so we are in a good position. But in 3-4 years, if the economy is going down, then the situation can rapidly change.
So maybe just going from that funding model into something that was mentioned, and we're talking about being on the forefront, and certainly One of the forefronts is AI and machine learning. So a lot of us generate data, and we heard about from our panelists about using AI and machine learning. So maybe if we could turn to the challenges and opportunities around using software, using databases, using AI to keep us on the forefront and to generate knowledge and science from the data that's generated at the facilities.
Maybe I'll just comment that there's an international consortium that is interested in the integration of omics data, and one of the problems that they have is agreeing on a standard. How should it be integrated? What should that look like? And so we have the tools, I think, to put some of that together, but I think it's a bit of a challenge when you're talking about, it's almost like the old Mac PC thing where you've got two different formats, somebody's wedded to one, somebody's wedded to another, and creating an international standard in our field for this sort of integration of glycomics, proteomics, transcriptomics, and genomics is a challenge, and it's going to take a little bit of head bashing maybe to get people to accept a standard.
Yeah, and the CLS, certainly we face that challenge with 22 beamlines and many different techniques, and so we're always looking for ways to consolidate that and to get some standard platforms. Maybe Naveed on your side?
So from our end, the challenge when you're dealing with genomic data, because of the kind of in some ways maturity of the technology, the data that comes out is we have ways and pipelines to make the data comparable, and we constantly work on that. I think in the health area, the clinical data are exactly the same as using the same standards to gather clinical data that is associated with that genomic data becomes an issue. But I think in general, for all large data sets, genomic data sets included, and the challenge we see is we do have the tools to be able to manage, share, store the large data sets. Where it becomes difficult is the cost of actually keeping that data, the cost of sharing that data, keeping whether it's local or cloud, and all the data security stuff that some we talked about, I think some we talk about tomorrow. But the cost of keeping that operational is fairly high because the data sets are high. So that's one of our challenges, that how do we, of course the beauty is, Mark, that if there are commercial solutions available, there are solutions that we can provide that are available, but who's going to fund it and who's going to continue to fund it? That's the issue.
Yeah, and given the overlap across the facilities with these needs, then maybe there's something that needs to be done nationally, maybe through CFI to consolidate and not have individual efforts across the different MSIs. So maybe Francois, you could comment on that as well, because we discussed also that because with a large user facility like ours, we have, and this other equipment, we have large maintenance databases and user databases, whereas you're more niche and more targeted, but you may still benefit from a common platform for efficiencies and not having to redo all the work that other facilities have done.
I agree. I mean, this we have discussed, and I mean, for ALS alone to build its own system for the users will be like, we will need to invest a lot of money that will then not go in for the salaries of engineers to work in the lab. So if we could give our shares within like a system where many facilities are contributing, that could be really helpful. And regarding AI, in our case, I mean, we already have a lot of users that are using AI, whether to optimize the laser, so AI to optimize the laser, this is quite common, or AI to improve the image reconstruction, using AI to do the pulse characterization. So AI is becoming really highly used in photonics, so we have to move this way, and within the technical team, some of our members have expertise with AI that we will provide to the users.
And just looking briefly across the Atlantic, we're part of a league of European-based photon sources, accelerator-based photon sources, and they're they're looking towards a science portal that doesn't necessarily focus on lasers or genomics or synchrotron, but focus on a scientific problem, and there's a portal that can then direct you to the different labs. Naveed, you were going to say?
I just wanted to kind of add one thing, and that's something for our board chairs, I suppose, to make a note of, is that we do have an organization called the Digital Research Infrastructure of Canada, right? And they should really, we should find out ways of how we can work with them. It's not that they don't have money, how we can work with them to kind of come to the party, so to speak, and help solve some of these problems. Because there is a national organization that should really be taking care of some, not all, but some of these things that we're talking about. But that collaboration or that integration is not there yet. And I think that needs to be taken, or talked about at really at the highest level possible. So perhaps the board chairs, when they meet tomorrow, that's one thing they can discuss and figure out a way how the MSIs can then better connect with DRAC.
Maybe just turning from the equipment and from the software to something that all of you have also mentioned, and that's the HQP, the staff. And so these are tremendously exciting places to be a part of, but all of us, I think, have the challenge of attracting and retaining qualified staff. So maybe we start with you, Warren.
Sure.
Your thoughts on that?
Yeah, so one of the problems that that we're running into with regard to applications of AI and machine learning is that programmers are paid very well in the private sector, and they're not paid very well in the academic sector. And so recruiting a good programmer is difficult. And if that's, if data integration is one of your directions, that's a real challenge for sure.
Naveed, maybe you could comment not just on programming skills, but also on hiring staff generally. Do you have a sense of how often you have to recruit the best person that you will train internally versus someone who's out of the box qualified for the position you're looking for?
Yeah, sure. So there's two categories, right? One's the people in the lab that are actually using the machines, generating the data, prepping samples. Those are the people that a lot of time will come in, we'll train them, right? And those are the people who hang around as well when we train them well there. But then the other box for us is data interpretation, data analysis, and those exactly what you're saying, Warren. And then that has really gone worse in the last few years in the thing they call the pandemic, because people are sitting in Toronto, Vancouver, Montreal, and being hired by US companies. They don't have to even physically move. And because of that, they're getting paid a lot more. So one of the other issues, I'll try not to spend too much time on this because you've touched on it earlier, Mark. One of the other issues is that in Canada, in the genomics area, we don't have data sets to do research on. We don't have human data sets, genomic data sets, like the US and the UK have hundreds of thousands, literally 100 millions of human genomes sitting in a database where researchers can do their research on. We don't have that. So then to try and keep researchers and bioinformaticians and people who analyze large data sets here in Canada becomes very difficult, because we cannot offer them the kind of the basic playing field that they can go and look at the data. So that becomes very difficult as well. I don't know, probably you feel something similar as well, Mark.
Yeah. And Francois, you mentioned that you've just had a hiring drive. So how did that go?
Well, in our case, what we found is hiring research associates with a PhD, it's not so difficult. There are many looking for jobs. The main difficulty is to hire technicians. People with, in Quebec, we have the cégep degree, like 3 years after high school. This is the most difficult because they are very well paid in industry. So yeah, it's surprising, but the people with a PhD, they are more available. We got applications from the US, we got applications from Europe. It's really not so difficult to hire people with PhD, but the technicians is really difficult. And then in terms of the HQP, but this is not really the responsibility of CFI, but you can tell HANSERC and the government, to recruit students is becoming very difficult because the funding doesn't increase to pay the students. And, you know, at INRS, the minimum is $22,000 per year. It's barely, you barely live with $22,000 in Montreal. So for Canada to have the capability to get the best talents from around the world, we need to increase the financial support to the students. This is the driving force for research in our labs.
So maybe on a related topic, so we talk about attracting staff, attracting students, attracting technicians. What about attracting users? Are there barriers that your facilities see for users? So for example, there are other light sources elsewhere that once you get beam time, then you also get a plane ticket and accommodation, because when you get the Nobel Prize at their facility, they want to it to be their facility. So maybe you can speak to any challenges or barriers to attracting users, be it data sets or equipment or access.
Well, I can start. No, this is, I mean, our users, they need to come on site, or a fraction of the team has to come on site. You have to do the experiments with the laser. You cannot do your PhD in ultra-fast science without touching the laser. It just doesn't work together. So you have to come on site, and the cost of hotel in Montreal has increased. I mean, like, it's really high. So it's becoming more and more difficult for the groups just to come. And we are in competition, for example, with Laser Lab Europe, where when you get beam time, they pay everything for you. So this is a challenge, and in particular at INRS, we are a small university. I heard the president of the University of Saskatchewan this morning, they have built an hotel. We don't have the resources at INRS to build an hotel, like on campus. So we are thinking of solution like renting condos, having a contract to a company that cleans it every week, charging a minimum to the people using it. But I mean, there are legal aspects into this that are very complicated if something wrong happened in the apartment. So, but yes, we have to improve the housing because hotel is just too expensive.
Yeah, for us, I think this is one area where we have done well as an opportunity, Mark, because we, when CGen, at least when I started with CGen, I was employee number 1, but when we started, there was a lot of samples or a lot of work that was going across the borders to China and other places, because there was run-of-the-mill service being done and data coming back. What we've done in the past 6, 7 years is that we have created a quality of kind of service that we provide that's beyond sample going on the machine and data coming out. The kind of experiment part where the experimental design part, and most importantly, the data analysis, data cleanup, all of that. That's something that people find is not very easy to get when you send your sample to China. And we've done really, like, we've spent a lot of time in making sure that we, at the end of the day, we offer something that others cannot offer. We do realize that for some of the things we just cannot compete on price because will be undercut every time by especially international participants. So what we try and do, and we have successfully done, is offer service that is of a quality, of an expertise that, and we work with the users and the collaborators to offer something that they cannot get anywhere else. And because of that, I think a lot of the users are attracted to CGen. There's still some small users who have small projects that really do just need data in and out, and they do come to us, but they do go elsewhere within Canada or abroad, which is fine. It's a small percentage. But largely where experiments that really push the needle forward in genomics in Canada, the large experiments, the large projects, we find that they come to us just because of that, because they have an actual person. They can walk into or email Steve Jones and have a discussion with him and use his experience and how to set up the project. So that's where we really use it as an opportunity.
Warren, what about your barriers for your users of samples?
Yeah, so we have kind of an interesting situation. So in terms of the services, I think, as I mentioned, we have some very unique services, and we don't have trouble attracting people to use those services. And one of the things that we have that's both an advantage and a disadvantage is we have this distributed group of services where training can happen at many different sites across the country. Cross-training then becomes difficult if you're in two physical locations. So it's both a benefit and a little bit of a hindrance. But I think because of the quality of the services that we offer, we get international inquiries frequently. People are very happy with the level of expertise that we can provide, and I think that's one of the things that, because Canada has a high concentration of people in that area, you know, we have a very good expertise base. So there are very few things in that area of glycomics that we can't address.
Now, it's always difficult being the panel that's holding everyone for lunch, but we do have a little bit of time left to throw it open for things that we may not have covered that people are interested in. So if I could just glance around and see if anyone has some other... Mohammed.
Okay, I think it's working. So thank you for this insightful discussion. So I have one comment and maybe a question. So on the data needs and the fact that all the MSIs are huge data producer and consumers, and the comment that was made in terms of, you know, ensuring a better coordination, I think I take your point, Naveed. It's a great point, and I will take it with me to Ottawa, and I think at a certain point we may organize a meeting with DRAC, right? And then maybe we can select a group of MSIs who are really big producer of data, and we can maybe find a better solution, an optimal solution for the nation. I think there is a lot of, I think there is a window of opportunity to have a certain economy of scale if we are to go in a national way, but we need first to understand the needs of these facilities. And I think the discussion also expands beyond the MSI, but it's a great suggestion, Naveed. Thank you so much. The question, a very quick question. You all agreed on the fact that the technology aspect is very important. So when people go to your facilities, they're not seeking access to the infrastructure, just the infrastructure, access to the infrastructure and the expertise. The expertise could start at the experimental design up to the data interpretation and how important it is. But I think at a certain point also, because you have very specific set of skills, these individuals also might be also important for the private sector companies, you know, who are developing new technologies. So how much in that is happening between you and the manufacturer of equipment in terms of pushing the boundaries and helping these companies also to keep innovating and producing, you know, better equipment? I don't know if some of this is happening with you guys, and if you can shed some light on it. Thank you.
Yeah, just very quickly, we are constantly working with manufacturers as beta testers, and that hasn't happened overnight. They have realized the quality of people we have who are tinkering with these machines and the amount of data we are generating. So manufacturers will often come to us and bring their beta technology for us to test, which is great because we get an opportunity to play around with it, and in doing so also figure out whether that's something we want to bring in-house for longer term or not. Of course, the challenge with that is that you need people or people's time to do that, right? So if the clock is ticking like a solicitor, where every time you do something you have to charge somebody, you can't charge this to a project, you can't charge. So some of it goes into the technology development part that CFI now has, or since kind of halfway through the last round, have graciously included. But we go out to other sources for the technology development part, but it constantly happens. At least at our MSI, we work very closely with, it's not so much as our people going there or their people coming in here. It's more about them sending us their beta instruments and us kind of kicking the tires, as they call it, and then figuring out the needs. Also, if we buy something off the shelf from them, we also have to sometimes redesign it for our needs. And that's where we work very closely with them. Sometimes if we develop a pipeline that's not offered by them but is good, they will take it and they will use it and commercialize it.
What about in the laser field? Have things come out that have now been incorporated in products, for example?
Yes, so we have companies that are coming to us because they have like technical challenges where our personnel can help them to figure out the problems and then improve their commercial products and further develop them. But we also have companies that just come to us, say, we recognize that you're really good. Can you train students in a project with us? It can be any project. We want to interact with the students such that we can hire them when they finish. Because it's very difficult for Canadian companies to hire abroad. But when you bring a student in, you build a relationship with a company. After the PhD, the students have access to a temporary work permit, and then they can join the company. So the companies are using our facilities also just to attract talents to Canada. Because there's just not enough young people in this country who wants to do laser physics. So we take students from abroad, we integrate them within companies, and for me it's great to see my students working with local companies and interacting, and after they build their life here and they contribute to our economy.
All right, well with that we've run out of time, but I hope you've enjoyed this panel discussion, and despite all the challenges, I think it's clear that all of the MSIs really are staying on the forefront of the technology and of the science and providing a great service to Canada. So with that, please join me in thanking the panelists and enjoy your lunch.